So next, we're talking about control flow. This is often involving using if-else, the condition statement, or something called a for loop, repeating operations. So we'll split these two. First, we'll talk about if-else conditions. So if-else condition, the basic constructs. This is more like the syntax, is that we start with if. You can see that.
Hey, Jane, can you put the microphone on your?
Oh, this.
Sure.
Thank you. Okay.
Yeah.
I'll try. Okay, so if you can see that here, if turns blue. So if a condition, we could say condition 1, or a condition is true. This is usually a logical statement. And then after the parenthesis, we'll use a square. It's not going to be square. It's going to be the same key, but you have to press shift to present this curly brackets. And I return my key. You can see that curly brackets start here and end here. So if this condition is true, we can perform one action, or action 1. And then followed by else, if else. It's the same pattern. Else, we perform action 2, another action, or alternative action. There are check mark here, but because this is only the constructs, this is not a art coding, but it kind of tell you the basic syntax of using if and else. So inside the first parenthesis, these are logical statements. So we'll take one example using this basic constructs. So for example, we start with the number x is equal to 8. And then we are going to modify our constructs. The first thing is that inside this parenthesis, it's going to be a logical statement for which condition is true. Let's say if we want x is greater equal than 20, we're going to, let's say 10. We're going to perform action 1. So the action 1 is going to print a message that says x is greater or equal to 10. And then else, we are going to perform another action. If not, that means else. If x is not greater or equal than 10, we're going to print another message. So in that case, x is less than 10. So now you can see that if we execute this, this whole thing, we're going to execute from the line 108, generate a number, and then we're going to check using our called if-else condition, control flow. So when you execute, you can see that because x is 8, which is less than 10, we're going to execute the other action, print x is less than 10. So we can also test multiple conditions by using else if. This is a slight, very subtle difference. So for example, if we want to have 3 categories, x is greater or equal than 10, and then x is less than 10, but it's greater than 5, and the third condition will be x is less than 5. All right, so before we only have 2 actions, now I would like to add 1 more actions. So for this one, if x is less than 10, but greater than 5, I'm going to print another condition. So in this case, instead of if else, only 2 options, we're going to else add if. Else if, that's going to generate multiple. You can have 3, you can have 4, you can have even many conditions. Else if, and then we are going to add another logical statement by adding this parenthesis. Inside this parenthesis, we're going to have a logical statement, which else if x is greater than 5, because when we have this else, that means it's already less than 10. So we added this 1 more condition, x is greater than 5. It's going to print x is less than 10, but greater than 5. And then after this, the third condition we could add will be, we add it right here, else. And then we're going to execute our last action, print x is less than 5. And then we conclude this curly brackets here. We can see the pattern. And again, if the condition 1, we're going to perform action 1. Else, if condition 2, we're going to perform action 2. The last one, that will be everything else. Else, we're going to perform condition 3. And then here you can guess what's going to happen if you execute. Let's take a look. So now it's going to print out even more detailed information because we have 3 actions. X is less than 10, but greater than 5. All right, any questions? Okay. All right, so let's move on. Find my cursor mouse. So we're going to talk about what's inside this parenthesis. That's going to be a logical statement. So R will evaluate the condition inside the if statement. It looks for a logical element. For example, if we can have another example here. We can have a logical statement for X. We use double equal sign to represent a logical evaluation of whether 4 is equal to 3. So in this case, X will be, we can execute this statement. X will be a false statement. And then when we use if, we could say if X perform action 1, let's print or you don't have to print 4 equal to 3. This means if this x is true, you're going to print 4 equals 3. And then next one will be else. You're going to perform the action print 4 does not equal 3. 4 does equal 3. So when we execute this if-else condition, we can guess it will, because x will be false, it will print the second statement. So this is to emphasize inside this parenthesis, it's going to be a logical statement. So if this logical statement is true, it's going to perform action 1. Else, otherwise, it will perform action 2. So now I'm inviting you to work on a challenge problem. Let's go to our notes. So in this challenge problem, you're going to use if statement to print a suitable message reporting whether there are any records from 2002 in the Gapminder dataset. So we have Gapminder's dataset. Hopefully you have already loaded into your RStudio. And then there is a year variable. We're going to so if there is any records from 2002, you're going to report how many their records are found from the year 2002. Otherwise, you're going to print out a message that records are not found for the year 2002. So I'm going to give you a little bit of time to think about this problem and to work on that, maybe with a partner or if you're in person. So for online students, if you are still working on that, you need a question, you can have a hand raised up. If you would like to, if you're done, you could use your green check mark.
Condition is blank, greater than 1.
Oh, yes.
Tell me.
Yes. We can talk about this general issue together. Yes, there is a common mistake. I can start to work on that example. So I have the data set right here. We learned to use if statement, condition inside a parenthesis, and then followed by an action term inside a curly brackets. So I guess your condition might be gapminder data set, and then you check the year, and then you check whether year is equal to the year of 2002, and then you're going to print a message records for the year 2002 found. So if you run this statement, you will have the issue. Let's try that. Look at the error message. This error says the condition has length is greater than 1. So this is a very important issue to remember that inside this condition, it has only to return 1 true. So you can use any function. So any is a function that's going to check all of the true. So if any one of a set of true or false is true, and it's going to be considered as true. An opposite function, kind of opposite to any, is called all. That's going to check if all of the true or false are true, it's going to be true. So any, you can see that any will only give you 1 true. If you only run this inside, that's going to give you a set of true or false, meaning. So this any is a handy tool. Alternatively, if you want to fix the issue, if you want to do this task using these hints step by step, you can also use what we talked about. So what we are really subsetting is subsetting from our gapminder data set on the year, which is equal to 2002. So this is a logical condition that's going to subsetting our data set. So we put a square brackets, and then we're going to put the condition here. And then after that, we put a, this is a comma. And this is only a data set. So we're going to check this data set's, the records. So yesterday you might have learned the function called the number of row, nrow. That's going to check how many records in the subsets. So if this number is greater than 0 or greater or equal than 1, you are going to perform this action. This is the second approach. So using what we have learned, you can see that how any function can do a sequence of steps, you subsetting the data set and then count the number of row. This is the equivalent to count the number of row, whether it's greater or equal than 1. This is equivalent to using any function. So this is a approach to the challenge question. Any questions? Oh, found it. Count the number of rows. What part of this accomplishes the task? Okay, so very good. So some other students, online students, have another solution. I'm going to show you from online students. They have used if 2002 is in the Gapminder year, and then you can print. Thank you for sharing. All right. Okay, any other questions online and in person for this challenge problem? All right, let's move on. Next, we're going to talk about a very handy function called a if-else. If-else function, let's say we have, if-else function has 3 arguments. If-else function has 3 arguments. The first argument is a condition. So condition is true. It's kind of like what we did here, this condition. And then the second function, the second argument will be perform action 1. It's kind of like this one, action 1. And then the last argument is the action, alternative action, kind of like this action. Alternative action. So that means if this condition is true, I'm going to perform action 1. Otherwise, or else, I'm going to perform condition alternative action. So let's modify this one. Suppose we have another number that's called a y is equal to 3, negative 3. And then the logical statement will be y, whether y is less than 0. And then action 1 will be, let's say, print a message called a y is a negative number. And otherwise, I'm going to print a message called y is either positive or 0. Oh, there we go. And then if we execute these 2 lines, you can guess what's going to happen. It's going to perform the action, the first action. Y is negative. So this is what we can see that. So if else is a function that kind of combine what we have talked about. If the condition is true, you're going to perform action 1. Else, it's going to do action 2. All right. And we also talk about any and all. So we're going to move on to repeating actions. The next topic is repeating action. So far, we talk about if and else. Sometimes we would like to repeating operations for a set of values. Repeating operation, in this case, we would like to use the for loop. Repeating using for loop. So I'm going to introduce how this for loop works. So like if else, for loop start with for, And then also, instead of a condition, inside the for loop, the parenthesis, there is going to be an iterator. Sometimes you could define I or J or any other number or character you would like to use. And then often we can use in, and after that, it's going to be a set of values. For example, 1 to 10, you can use 1:10. And then after this looping condition, we're going to have our actions inside this curly brackets. Action or actions. So next, we're going to modify this, see how we can use this constructs of for loop. Let's say we have iterator to be considered, call it I. And then set of values is going to be from 1 to 10. 1:10, that's going to generate a number 1, 2, 3, 4 up to 10. And then our action, let's make it easy to be print I. And we can execute and see what happens. 1, 2, 3, 4 up to 10, they have been printed. So we are doing the print action over and over again for each of the iterator. All right, so we can also have more than one for loop nested within another for loop. For example, once we have this first for loop, let's say we go from 1 to 5, and then we can define another for loop inside this curly bracket called for j. And j is going to go from a collection operator that goes from A, B, C, D, E, A, B, C, D, and E. And then after that, we're going to print ij together. So I'm going to introduce a function called a paste. Paste is a handy function to combine two objects together. We are going to combine I and j, so you can expect it's going to be 1a, 1b, 1c, and then repeating for each I, and then after that for each j. Note here, after this for loop, we should have another curly brackets. So we can put our print here or remove this curly brackets down here. So you can see the format for the inside the first for loop, we have nested another for loop to print the alphabetical letters. So once we execute this one, we can see the for loop are nested. And then that for each one, it's going to print 1a, 1b up to 1e, and then repeating this for 2 and 3, 4, and so forth. So our next one, we are going to slightly modify this. And often when we print the results, we would like to save the results in another object. So I'm going to modify this instead of only printing in the console window. Let's say if we want to save our results. So first of all, let's say output vector. There are two ways to do output vector. For the sake of time, I'm going to show you The first way is going to, we just use collection operator and leave nothing inside. And what this one does is that it will grow your results computationally. We use the for loop, but instead of using print, we're going to save our results into a output. Let's say we want to call it temp output. And then following that, we're going to, each time, we're going to grow our output vector because it was nothing. It was nothing initialized here. And after each loop, we would like to grow our results using this collection operator. So using what we have originally and append with this temp output. And then once you run this output vector at the end, after your for loop, you can see that output vector has been growing. Let's do the first one. You can see what happened in your environment. Make them smaller. So this one was null. And then after your for loop, you can see what's happening after. So output has been growing to what you would expect, 1A, like before, outputting the console window. But now you have an output vector, an object to manipulate if you wish. Another way to save the results will be called, first we define that instead of null, we could define that into a matrix. What we are doing is that, let's say if we want to define that into a matrix, for matrix, we can define the number of rows and the number of columns. So we're putting these information into 5 rows and 5 columns. The rows are going to give us, for example, A, B. So I will be the number of rows. So the rows will be 1, 2, 3, 4, 5. And then the columns are going to be A, B, C, D, E. So when you combine them together, so let's say we could have a temp value stored up here. So output vector, output instead of vector, it's going to be a matrix. 5 rows and 5 columns. Let's define J vector. Why do I do the J vector? So that instead of J from this list of characters, I'm going to short that to be, store that into a J vector. And you can see why, because when I for J loop, I would like to make it into 1, 2, 5, 2. So this will make me easier to index the output matrix. So that will be I and J. This is the first changes I made. And then my temp value, temp J value, it's not going to be J. It's going to be a temp J value. You can use J underscore vector and then use J to index A, B, C, D, E. And then my output matrix is going to be indexed by I, comma, J. And then this one is going to be the temp output. So every time you have a temp output, you could save that into the appropriate place inside this matrix. So if I run this one, if you would like to output your matrix as a vector, you can also do that. Output vector 2. That's going to be as dot vector, and then using output matrix. And after that, we're going to output the vector 2. So you can guess what's going to happen here once you execute this command. Oops. Unrow, uncolumn. I misspelled the C. Let's do that again. Output vector not found. Let me double check on that. 155. Oh, that's right. I missed the T. Thank you. All right, there we go. So you can see that compare with our output vector. Now they're listed, I think they're by rows first. 1A, 2A, 3A, 4A, 5A. I think by columns first, excuse me, because the numbers represents the rows. And then when you make that into a vector, it will stack up each column together to make a vector. So the first column stacked together with a second column, and then this will be the third column. So here's a challenge question. How do you make a little modification here to make that the output vector 2 will be the same as the output vector 1 earlier? So you can see that they are essentially the same thing inside. You can also double check on that. But what if you want they are in exactly the same order? And to show you our challenge question down here. So how would you change the last little chunk of code to make the two vectors the same? Think about this line or this line. There are tiny bit of changes you can try. If you would like to catch up quickly, you could go to our learner notes, and we have covered two ways of doing the for loop. One way is to growing your vector. Another way is to predefine. And the predefined way is often the better way for computationally efficient. The only thing we found that is output vector 2 is slightly different from output vector 1 in the order. So what do we do if we want them to be output vector 2 to be the same? All right, for the sake of time, I'm going to, let me see the online students.
Run myself, but you took these lines, after 137, but that's 145
All right, I'll quickly present the solution. It's actually very easy. If you change ij when you identify the matrix to be ji, you can see how that will change on the matrix. Let's take a look at what the matrix right now, output matrix. It's 1A, 2A, and the columns is arranged like this. If you change ij, so for example, 2 and 3, this one will be 3 and 2, 3 row and second column, 3b will be represented by this one. That will be the same. So instead of doing ij, we're going to change that to ji, and now you can see how the matrix has been changed. Now you can also see the matrix have been changed. So before we have 3b here, now 3b is right here. So it's kind of transposed. That will do the trick. Another way, of course, you can transpose the previous matrix by using T function. And the solution will be posted in the learner notes. All right, thanks everybody. We're going to take a little break. And afterwards, we're going to talk about plotting.